Aluminium is the most widely used light metal in the world. It has been used increasingly for decades because of its abundance, low density, good machinability, and resistance abilities. Aluminium is the third most abundant element in the Earth's crust, after oxygen and silicon. However, it does not occur in its elemental form in nature. It can only be produced economically from bauxite. First, aluminium oxide, or alumina, is extracted from bauxite, and then the alumina is transformed into liquid primary aluminium, which is cast into ingots, billets, and slabs. These are then processed into the final product. In developed countries, a large proportion of scrap aluminium, like soft drink and beer cans, is recycled. Recycling these cans saves 95% of the energy that is required to make the same amount of aluminium from bauxite. Aluminium smelting consumes vast amounts of energy, so aluminium smelters are found mostly in countries where there is an abundance of electricity and energy resources. More than half of the aluminium smelters use electricity generated by hydroelectric power plants, and only a small number of them use electricity produced by coal-fired or other fossil fuel power plants. In general, 2 tons of alumina can be extracted from 4 tons of bauxite, and only 1 ton of aluminium can be produced from this amount of alumina. Liquid primary aluminium is produced from alumina through electrolysis, a chemical reaction triggered by electric current. An anode, that is, a positive electrode, and a cathode, a negative electrode, have to be immersed in an electrolyte solution and connected to a direct current source for electrolysis to occur. Aluminium production takes place in steel tanks that are lined with graphite blocks. This graphite lining functions as the cathode. The melting point of alumina is over 2000 degrees Celsius, so it is dissolved in molten cryolite, which has a lower melting point. The resulting electrolyte solution has a temperature of about 1000 degrees Celsius. Then, a carbon anode is immersed into the solution. The oxygen atoms in alumina are given off at the carbon anodes, and then these atoms react with the carbon, forming carbon monoxide and carbon dioxide. Molten aluminium is deposited on the graphite lining, i.e. the cathode, at the bottom of the tank and takes on the role of the cathode. Molten aluminium is tapped off each day or every other day into a ladle. Since the oxygen is collecting at the positively charged electrodes, it is continuously oxidizing the carbon anodes, which therefore must be continuously replenished. A solid crust forms on the surface of the electrolyte solution, and alumina is added to this solid crust. This crust helps heat the alumina and prevents the electrolyte solution from losing heat. Once alumina is added to the crust, it is broken periodically to replace the broken down alumina. In aluminium smelters, hundreds of tanks operate 24 hours a day, every day of the year. Since the volume of the aluminium extracted by electrolysis is directly proportional to the amperage used in the process, a very strong electric current is used in smelters, but the voltage is low to keep the process economical.